All right, section 2.6, we're going to be discussing what are called piecewise defined functions today. These typically have been tricky for students in the past, so please feel free to rewatch this video or parts of this video if you are confused on something here, okay? What we're going to be doing today is we're going to be graphing, instead of an entire line, we're just going to be graphing a portion or a piece of the line on a certain domain. Okay, so instead of graphing, say, maybe all the way from negative infinity to positive infinity, we may only be graphing a line for just the values that are less than -1 on the x-axis. Okay, so let's take a look at what the definition is for piecewise functions. Okay, piecewise defined functions are anytime you use either two or more expressions. Each will have their own unique domain. Please keep in mind that these are functions. Therefore, when you get to the end of the problem and you actually have constructed the graph, that means these graphs should be passing the vertical line test. Okay, so here's how your graphs are going to look, and I'm just going to flip to the back of this notes page so that we can look at some of these graphs here. This is what I mean by graphing a piecewise defined function. You can see on this graph here we have array that's starting at an x value of 1, and then it's carrying to the left, so it's including all the values to the left of where x is positive 1. Here's a segment that only exists from the values where x is 1 to where x is 2. Okay, so it's just a piece of a line instead of the entire line. And then over here we have an array that is starting at an x value of 2, but then it also exists for all x values that are greater than 2 because it's going to the right. Okay, piecewise functions can be comprised of just two pieces or 3, 4, anything like that. Okay, so let's go back to the front, because our objective here on the front is, given the equations of the pieces and the domain restriction for that piece, we want to be able to construct how the graph would look. Okay, so here is, we'll talk about whether the dot should be open or closed here in just a moment. Okay, here's what I want you to do when you are doing these problems. Okay, I want you to go ahead and construct a very small XY table that would simply hold 2 points in it. Okay, and the way these piecewise functions are, it looks a little bit weird. You kind of got to get used to how this looks here. You see this f of x that's out here on the left? We know that represents the symbol y. Okay, this is serving the purpose y equals x minus 2, and then also y equals the equation x plus 3. So instead of writing each of these equations with two separate f of x equals, this brace here is kind of telling you that this serves for both of them. Okay, so we don't want to graph the entire line y equals x minus 2. We only want to graph the section of the line starting where x is -1, and then for all values that are smaller than -1. Okay, so what I'd like for you to do is, and by the way, every row you see here, that generates a different piece or graph to your piecewise function. Okay, I want you to take the first piece, and I'd like you to write that equation at the top of the XY table that we made here. Okay, so we're just working with this top row right now. We'll come back and deal with this bottom row here in a minute. Okay, the first thing you're going to do is you're going to take the value of your domain here. Okay, so -1. And you're going to use that value as your first x value. This is going to give us a sense of where this ray is going to begin. Okay, so you're going to use -1 for your x value, and then you're going to plug that -1 into the equation right up above here for the x. And you can do this in your head. -1 plugged in here for the x, and then subtract 2. That would give you a -3 for the y value. Okay, now here's the catch, and this is the part as to whether, when you plot the point -1, -3, should you plot that point as a closed-in dot, or should you plot it as like an open dot? Okay, that's the question. Okay, here's how you tell. A closed dot means the graph includes the point. So if your inequality symbol has an equal to bar underneath it, so either a less than or equal to bar or a greater than or equal to bar, it means it's equaling that point and you would want to close it in. If your inequality symbol does not have an equal to bar underneath it, so just a less than or a greater than, then it means you're not actually including that point, and you would make that point then open. Okay, so let's look at what our symbol is. Our symbol is just a less than symbol. So I'm going to just make a little note to myself that when I plot the point -1, -3, I'm going to be plotting that as an open dot. So let's go ahead and come over to -1, -3. Keep that as an open dot. Okay. Now, when you are only given one value over here in the domain, and what comes after the word if, this is the part that's your domain. We were only given one number, that was our -1, and we use that right here. Then that means that this graph is going to look like a ray. Okay. It would look like a segment if after the word if, like in example 2, you can see how there are actually two x values provided for you. If you only have one, you use the one that you are given, and then you need to choose a second x value. Okay, now here's the restriction. You have to pick a number for x, but it has to be less than -1. Okay, it has to be in agreement with what the domain is here. So any number, as long as it is smaller than -1. So I'm going to choose -2. I'm going to plug -2 right in here for the x. So -2 minus 2 more, that would give me a y value of -4. Okay, now any point that you're choosing on the rest of the ray, all those points are closed. Only where the ray is starting is the only open point. Okay, so you're going to go ahead and plot a point at -2, -4. But then you're going to move your pencil back to this starting point, -1, -3. And you're going to start there and run your pencil through the point -2, -4, but keep going past that and draw your arrow. Okay. Once again, this piece is a ray, and this first point here is where the ray starts. Okay. Now, if you look at what we have here, we have actually graphed the line y = x - 2, but we only graphed the section of the line starting where x is -1 and everything less than that. So it went to the left there. Okay, so let's go ahead and try the second piece. We'll do this one a little faster. Go ahead and make an XY chart. I'd like for you to write the equation of this piece up above it. So f of x = x + 3. Okay, let's go ahead and use the one number they give us. That's the -1. We're going to plug that in for this x, add 3 to it, we get 2. Okay, now let's look at the inequality symbol. Does this inequality symbol have an equal to bar underneath it? This one does. So that means we're actually going to include this point. We want to make this point closed. So I'm going to make a little note to myself that when I go over here and I plot -1, 2, I'm closing that one in. Okay, this also only gave me one number, so that means this piece is also going to look like a ray. I get to pick what my other x value is, but I have to be careful. I have to make sure I'm picking an x value that is greater than -1. Anytime you have the opportunity to choose a 0, it's just an easy substitution to make. So I'm going to pick 0. You could pick any number as long as it's greater than -1. If we plug 0 in here for the x, it looks like we're getting back out a 3. Please remember, all other points on the ray are always closed. It's only the first point that could be open if the symbol didn't have the equal to bar, but this one is also closed. Okay, so I'm going to plot the point 0, 3. And then you're going to start with your pencil back at the original point, -1, 2, and run the pencil through the point 0, 3 and draw an arrow. Okay, and here we have the two rays, only this is the line x plus 3 for all values starting where x is -1, but that now this is including all the x values that are greater than -1, okay, greater than or equal to actually. Okay, now this is asking us then to go on and go ahead and state the domain and the range for this graph. Okay, so I'm going to put a D with a colon and an R with a colon. Remember, domain, those are your X values. So what you want to do is you want to look at this graph and have your eye start all the way on the far left. Pretend this arrow extends forever to the left. The very smallest x value that would be included on this graph would be -infinity because this continues to the left forever. So as you work your way from left to right on this piece, you'll notice this piece stops at an x value of -1. In fact, this piece doesn't include -1. However, look at where the other piece picks up. This one stopped at -1, but this piece picked up at -1 and is saying to include -1, and then if we follow this from left to right, since this is an arrow, it goes on and on forever, it would include all the x values all the way to positive infinity. So when these two are combined together, they kind of connect right here. Okay, we could say that the domain is all real numbers, and we'll just use that symbol there for all real numbers. Now let's look at the range. Remember, range, this is your y values. So instead of starting all the way to the left, you want to be thinking of the y-axis and say you want to start at the very bottom of the graph, which also happens to be right here. Now, even though, yes, this section does go to the left forever, it also is tilted, so it's going down forever. So if I asked you, what is the lowest y value, you would say this is going down, down, down to -infinity. But then as you go from from bottom to top, this piece is stopping right here. Now, what y value is this stopping at? Okay, make sure you're looking at the y-axis. It's stopping right here at a y value of -3. Now, unlike the domain, there's this gap here. See, this piece right here, that piece isn't starting until you get to a y value of 1. So these pieces are disconnected. That means when I state the range, I'm going to have two different parts to my range. That lower piece, I'm going to say, goes from -infinity to -3, and I'm putting a parenthesis because it's an open hole. It's not including the -3. And then the other piece is starting at -1, but I'm putting a bracket here because it's including the -1, and then it goes all the way up to positive infinity. Okay, we always put parentheses around the infinities. Okay, and this would complete saying the domain and the range, and we completed our graph there. Okay, so let's go ahead and just try one more of these here. We'll look at example number 2, and then we'll shift to the back here. Okay, so if you recall, this is going to have two pieces to it because there are two rows. I'm going to go ahead and draw an XY table. I'm going to put the equation of the first piece, f of x equals x plus 2 at the top of that table. And what's different about this first piece is they give us two numbers here for our domain. When you are given two numbers, that tells you that this piece is going to look like a segment. They are giving you a distinct starting and stopping point. So you're going to go ahead and use the first x value, -5. You're going to plug that in for the x, add 2 to it. That gives you a y value of -3. You're going to look at the symbol, this symbol right here in between the -5 and the x. If it has an equal to bar, remember we said if there's an equal to bar, that point is closed. So I'm going to make a note that that point's closed. I'm going to come over here and plot -5, -3 as closed. Now, if we only had that number, this would be array, and I would pick my own other number. But I have a second number I'm given. I'm given the 0, so I'm going to plug 0 in for the x, add 2 to it. That's going to give me 2. And then I also need to look at the symbol now in between the 0 and the x. This symbol does not have an equal to bar, that means I'm not actually going to include this point. I'm going to make it open. It's going to be an open dot. So I'm going to make a note to myself, that one's open. So I'm going to plot an open dot at 0, 2, and then I'm simply going to use my pencil and connect those 2 points together to get the segment. Okay, now my second piece is just the equation f of x equals x. Okay, so I'm going to make another xy table. This one, though, I see they only give us one number. So I know this one's going to be array. I start always with the one number they give us, which is a 0. And I'm going to plug 0 in for the x. Well, if I plug 0 in for the x, what I'm going to get back out is a 0. Okay, I'm going to look at my symbol. I see it has an equal to bar. That means I'm going to make a note. Then I'm going to be closing in the point at 0, 0. And now, since this is array, I get to pick whatever number I want as long as it's in agreement with this inequality symbol. It has to be an x value greater than 0. So I'm going to go ahead and choose 1. If I plug 1 in for the x, looks like I'm going to get a 1 back out. Remember, all the other points on array are always closed. I'm going to plot it at 1, 1. Now be sure that you start your pencil back at where the ray started at 0, 0 and run your pencil through that point. Okay. Remember, these are your final graph should always look like it passes the vertical line test. So I'm just going to demonstrate this here for you. I could draw vertical lines all the way through here and they would only touch the graph in one point. Even right here, it's only touching at one point. Because remember, this was open, so there's not really a point there. Okay, if you ever get a graph, and I'm going to just draw a graph here. If you have a graph that would ever look like this, you would automatically know you did something wrong. Because this graph doesn't pass the vertical line test. Here I drew a vertical line, and it's crossing my graph in 1, 2 places. Those are repeating x values, okay? All right, let's go ahead and do the domain and range on this, and then we'll take a look at one problem on the back where we're going the other direction. Okay, for the domain, start all the way on the far left of the graph. You're looking at the x-axis and say, what is the smallest x value all the way on the far left? Well, for this, it looks like it's this point right here. Looks like that is -5. Okay, so my smallest x value is -5. Now I'm going to creep from left to right. When I stop on the segment here, that's an x value of 0. But look at this other piece. It's picking up where that piece left off at an x value of 0, and then it's carrying the graph all the way to the right forever. So these two kind of connect to each other when I think of it horizontally. So this graph starts at -5, so I'm going to put a bracket because it's including -5, and then it carries and includes all the x values to the right of -5 because of the way that these two connected. Okay, now let's look at the range. You want to start and find the lowest y value. Looks like that y value is -3. This piece stops at a y value of 2. It's not including 2, but look at this. This piece, it includes a y value of 2 right here, and then it's carrying the graph up and including all the y values even higher than that. So I'm starting at a y value of -3, and the graph kind of overlaps and connects a little bit here where it includes all the y values then bigger than -3. Okay. All right, we're going to flip to the back and we're going to try one problem where we're going to go the other direction. This is where you are provided with the graph and you are asked to come up with the equation of each of the 3 pieces. In addition to creating the equation, you will need to come up with the domain section for each of the 3 pieces. Just the domain, not the range. What comes after the word if is always the domain. Okay, here's the best way to organize this. How many ever pieces there are. I like to kind of make a separate column, first, second, third, representing like in order from left to right. Okay. If you're going to make an equation, guess what we need? We actually need to know what the slope is for the piece, and we need the y-intercept, okay? And then we can just use that part here, okay? Let's go ahead and set up how our final answer would look. I think we're going to write this underneath the graph. Let's go ahead and put our f of x symbol. We'll go ahead and put a big brace there. Okay, I'm going to draw 3 lines here, one for each of the, like it would be this part, mx plus b we'll need to put for the first piece, second piece, and third piece. I'm going to put the word if after each of those, and then we will also fill in just the domain of each piece separately. Even if it connects to the other piece, we do each piece separately when you're writing it this way. Okay, so as you look at this first graph here, I'm fine with you counting rise over run on the graph, but you do need to locate like 2 points on the graph where you can tell it's crossing like at the corner of the grid, and then you can just count rise over run. So it looks like we're going up 1, 2, 3, 4, rise of 4, run to the right 2. I'm going to say the slope of this, 4 over 2, is 2. And it's not negative, because if I set a car on this and had the car travel from left to right, it would be going uphill. So don't be deceived because you feel like that arrow is going down. This is a positively sloped line. Okay. Also, if you can tell by looking at the graph clearly where it is crossing the y-axis, then you can just write down that the y-intercept looks like it's at 3. Okay, I'm going to go ahead and put those 2 pieces together. 2 is our slope, 3 is our y-intercept. So for this first piece, and you're not writing the y equals because that's taken care of right here with this f of x, you're going to fill in 2x plus 3. Okay? All right, let's go ahead and do the domain. This is array. If it's array, you're only going to have one number with the x. Okay? Now, I encourage you to leave a gap for the symbol. We'll come back and fill that in. Let's just put the x value of where that ray starts, okay? Starting meaning right here, okay, because it goes on and on forever down here. This ray looks like it starts at an x value of positive 1. So I'm going to fill that right there. Okay, then look at the direction that the ray is going. Is it going in the direction where the x values are getting less than -1, or is it going in the direction where the x values are getting greater than -1? This is definitely going to the left, so it's where the x values are getting less than -1, so you should choose a less than symbol. And finally, look at the point. If it's an open point at 1, then you should not put an equal to bar underneath. Had this been closed, then we would fill in an equal to bar. Okay, let's move on to the second piece. Okay, the second piece, I'm just going to count rise over run. So it looks like to get from one point to the next, we would be going up 1 and then to the left 1. If you're going to the left 1, that means our slope should be negative. And again, if you picture a small car going from left to right, the car on this one would be going downhill. Okay, now to get the y-intercept for this, okay, what I want you to do, if you cannot physically see in the graph where that piece is crossing the y-axis, I want you to use point slope form. I understand on this particular example, you technically could use that slope up and over to estimate what it would be, but you're going to run into some problems that aren't going to be this easy. That also, some problems could have a y-intercept be at like 1 2/3 or something kind of crazy. Okay, so the rule is going to be this. If you can see it, if it's physically touching the y-axis and you can clearly tell the y-intercept, write it down like we did on the first piece. If it is not touching the y-intercept, I want you to use this point slope form. I want you to pick a point and use your slope and go ahead and substitute that in. So let's see, what's our point? 2, 0. Okay, we're going to use 0 for our y1, -1 for our slope, and then 2 for our x1. I'm going to ask that you solve this equation for y, and bam, right there is what we're going to use for our mx plus b for this second piece. Okay, now if it is a segment, for your domain, you're going to always set it up like this. Put an X in between what looks like 2 less than symbols, but this first symbol is actually acting as a greater than symbol. Okay, so you're going to set up segments like this. What you're going to put on the left is the x value of where the segment starts. That would be a +1. And what you're going to put on the right is the x value of where that segment stops. That would be a 2. Okay, now we're left with whether we need to put equal to bars under these or not. Both of these segments were closed in points, so we want to put an equal to bar there showing that we are including that point in the domain. Okay, the last piece is a horizontal segment, or excuse me, a horizontal ray. Slopes of all horizontal lines should be 0. Here is the one exception to my, if it's not physically touching the y-axis, you have to use this point slope form. If the segment ray is horizontal, then go ahead and just visually extend that over, and you can conclude that it would obviously be crossing the y-axis at 3. Okay, horizontal lines are an exception here. Okay, now when we write the equation, you can write it 0x plus 3, or you could just write it as 3. Okay, this is a ray. I'm going to give an x. I'm going to write the x value of where that ray starts. It looks like it's starting at 2. And then I'm going to choose a symbol, greater than or less than. Well, let's look at the ray. What's it doing? What direction is it going? Well, it's going to the right. What happens to the x values as you go to the right? The x values are getting larger, so I'm going to choose a greater than symbol. And finally, should we put an equal to bar underneath that? We should not, because at x equals 2 on this ray, it's an open dot, meaning we're not technically including that point. Okay, the answer to this then is all of this right here. That's us going the other direction where we're trying to come up with the equation for the graph that we're given. Okay, I filled in a little bit of each of this last one here. I just didn't